Welcome to Sundar's lecture. This is lecture number 64, and in this lecture we are going to see solving differential equation by classical method. See what are all the topics we have seen in the previous class. See, we have concluded with discharging energy in an inductor, right, or from the inductor. See, we have concluded one thing in the previous class. This is the expression for RL circuit, and this one you have to clearly understand before entering into the solving differential equation. We need to know exactly this one so that we can easily relate the differential equation with our electrical circuits. So I of t is equal to E by R minus E by R e power minus RL by t. So this one I have told you, this is solution due to forcing function, and this one I have told you, this is solution due to natural function. And you try to understand, this one always becomes 0, and we have seen that, right? See, you can easily see here. Yes, this one. See, this is the I of t expression. Anyhow, if you multiply this one, you will get this E by R minus E by R e power minus R by LT. But at last, finally, when you give stipulated time, this term will vanish. This term will, that is what we have seen. To r t is equal to infinity, you will get E by R only. You don't see this one, this natural function, solution due to natural function. Try to understand or keep in mind these kind of basics. We will go to the solution, solving differential equation by classical method, right? See, first we will take for the first order differential equation, and this is not the method where we are going to see complementary function and a particular integral. I'm going to solve this in a different way. Try to understand. I'm going to prove my expressions. See, I'm not going to tell you directly. You do this one. This is the solving of differential equations. For that, I need to give you a proofs. That is what I'm going to do in this particular lecture. And we will go for first order differential equation, and then we will go for the second order differential equation. That in my future lectures, right? So first, this is the first order differential equation. See, I am taking the common notations and we try to relate that with the electrical one, right? Because now I have taken it as dy plus ay is equal to x of t, all those kind of things. First, you should understand this is the forcing function. Forcing function, which means what? Which means what I have told you. Forcing function means in electric circuit it will be a voltage. It will be a voltage. There should be some voltage in the electric circuit, and this is nothing but that voltage circuit, right? So when you see an equation like this, first I try to multiply integrating factor. What is integrating factor? I have already told you, right? It is e power at. That is the integrating factor. We have seen this one. Anyhow, we have seen this one already. So we will multiply with integrating factor. So what you will get? It will be e power at dy by dt plus a into e power at e power at y. See, here it is y of t. I am not writing it y of t because I have already told you, while writing I there in, we would have written it as current in our electric circuit. Anyhow, I am not writing y of t in all places because it will be congested to see, right? So I am not writing it. But this one, it will be x or x of t. If I write x, it is defaultly you have to understand that as x, right? So this is now we have multiplied with the integrating constant, right? Now what you do, you can write this one, right? How you can write this one? This is nothing but d by dt of e power at into y, which means uv formula. I have already told you, this is uv formula, right? This will be e power x of t into e power at. Now I just want to integrate on both sides. Integrate on both sides. So see here, I am just integrating on both sides without any limits. So what I will get now? I have to get a integrating constant, right? So if I integrate this one, you bring this dt to other side and integrate, you will get here, it will be e power at y will be is equal to, if I integrate this one, If I integrate this one, I will get integration of e power at into x of t plus this constant. This constant, it is coming because of what? This is integrating constant. Integrating constant. Why this integrating constant is coming? Because I'm just going to integrate without limits. That is the only reason this integrating constant is coming to us, right? So next step, what we are going to do, we can write this as, we can write y of t will be is equal to, I'm just going to bring this to the other side. So what I will get, this e of t will be divided by this whole term can be divided, and with this term this e power at can be divided, right? So I'm just writing it in the numerator. What I will get? I will get e power minus at integration of e power at x of t plus it will come in the division in the denominator, and I'm just writing it in the numerator by putting minus, right? So that you know already, these kind of things are all very basics, right? So next what I'm going to do, see, this is now integration, right? E power at, e power minus at is already there, so keep e power minus at as it is. See this one, I'm going to integrating by parts. This is the first part, this is the first one. Maybe I will take it in a different way. See, I'm going to write this expression. Maybe I will do it in a different way. So, y of t, I'm just writing y of t is equal to e power minus at, and integration of x of t, I'm just changing this one, e power at plus this one is already there, e power minus at. Now you see, I'm going to integrating these two by parts. By parts means what? This is first part and this is the second part. I'm just taking this one as first part, this one as the second part. Try to understand, don't think that, oh, there are so many integrations are coming down. Please let me do this one, and I'm going to give you a final solution where you don't see any integration for doing the differential equations. That is what my ultimate aim. Please be with me so that it will be easy to understand, right? So you don't look into this one, but for proof I have to do these kind of things. So this will be is equal to e power minus at. See, I have to put a bracket. See, this one integrating by parts, what you have to do? You have to keep this x as it is. You have to keep this, see, I will put it as x now. You have to keep this x as it is, and then you have to integrate this one. It will be e power at by a, I know that, and minus integration of differentiation of this one, differentiation of this one, and integration of this one. That is the integrating by parts, right? You have to keep this one, you have to integrate this, minus, put integration, and you have to differentiate this one. See, I'm not going to, I will write it down here, d by dt of x of t, I will simply write it as x dot. I will simply write it as x dot. So this will be now x dot, and if you integrate this one, what you will get? It will be e power at divided by a. That's all. Then it will be dt. So I have missed dt. Dt everywhere you will see dt's. Everywhere you will have a dt terms. Please, you just try to understand this, right? So this will be plus a e power. This will be completed. So this will be now e power t. So what is the next step now? So this will be now e power minus at. See this e power minus at, I can just bring it to the inside bracket. So what I will get, this term will be cancelled out, right? It will be 1 now. So what I will get? I will get 1 by a into x, and then I can bring this to the integration. So it will be my e power minus at minus e power minus at integration of x dot e power at divided by a into dt, and then I have this term plus a e power minus at, right? So now what I can do, I can further go for the next step. I just try to simplify this one I have, right, up to this. Then I need to integrate this one again. So if I integrate this one, what I need to do, I have to keep this one parts by parts, and then I have to integrate this one. See, and this a I bring outside because there is a I can bring it outside. So e power at I have to differentiate it. So sorry, integrate it. Then I will get e power at divided by a. This a I have already brought outside. And then what I need to do, put minus integration of, I need to differentiate this. So this will be x double dot and e power at, if I integrate this one, what I will get, e power at divided by a will be there, right? It will be dt. Then this term is already there, e power minus at. Now this term, please hear me, because I am doing so many things. There are so many integration, again and again I am going for the integration by parts, but the final answer will be very interesting. You see, with the final expression you can directly solve the differential equation. I want to prove that. I don't want to write the final expression directly, you solve by this method. No, I will not do that. I need to prove, and I will show you this is the perfect procedure to solve the differential equation. Anyway, so this will be now like this. Then I will bring this to inside. What I will get, this one, if I have minus here, so if I bring this one inside, this will be cancelled out, and I have 1 by a square x dot will be there. Then if I bring this to the integration, then what I will get, I will get plus e power minus at divided by a. See, I bring this one, but I will also bring this one to outside, right? So what I will get, I will get a square here, because this one is already there. And then if I bring this one outside, so what I will get, integration of x double dot e power at into dt plus a e power minus at. So if I further do one more step, it will be 1 by a x, then it will be 1 by a square x dot, then there is a plus, then it will be e power minus at divided by a square. And then you see, if I integrate this one, this term will be as it is, right? This term will be as it is, and then I need to integrate this term. It will be e power at by a. It will be like this. I just bring this to this side. So now it has to put, I have to put minus integration of, I need to differentiate this, so it will be x triple dot. I need to integrate this, so it will be at divided by a, and it will be now plus a e power minus at. So this term, I will go to the next page, so I need space. So I will take it to the next page, right? See, one thing I have missed it out. See, this is a square, right? This is a square. I have written this one anyhow, and then you see, I have just taken it to the this a square will come here. That one I have missed out. So I have written this expression. So now it is getting very complicated. Anyhow, I will wind up with this now. We will just stop with this. So this will be now 1 by a my x, then this will be now 1 by a square x dot, plus if I bring this inside, these two terms will be cancelled out. So what I will get, 1 by a cube x double dot, and then it will be minus, and I have to bring this to inside to the integration. So this will be now like this, right? So integration of x double triple dot e power at by a into dt plus a e power minus at. See, try to understand. Now it is very clear. We can easily understand what is going to happen. What is going to happen now? See, it is 1 by a x minus 1 by a square x dot plus 1 by a cube x double dot. Then what should be the next term? Next term will be minus 1 by a power x triple dot. Next term it will be increasing, right? It will go to infinity. So we are not going to solve this expression to infinity anyhow. See, this is very important to understand. Try to be with me. This will be now y of t. I will just write it as k1, but this is a constant value, right? I have already told you. What is a? It will be a constant value. A will be a constant value. So this one, I can write it as k into x. See, this with this minus, I will take it as a constant. So plus k2 into x dot, and then plus this one is a constant, k3 into x double dot, plus k4 into x triple dot. This will now go to infinity. This will now go to infinity, plus, and this term is already there, right? So this will be now e a into e power at. Try to understand. This is the solution for the differential equation. Now I will tell you one thing. See, from here to this point, what is this one? This is nothing but solution due to forcing function. Solution due to forcing function. What is forcing function? What is forcing function here? In our example, x of t is the forcing function. See, only x of t will come. Higher order derivatives. Constant with x, and then it will go for higher order derivatives till infinity. Till infinity. So it looks like this one. See, while solving a problem, it will be very easy to understand. Now, what is this one? This is nothing but solution due to natural function. And why I am saying this one? See, this is system constant, a, which is nothing but a constant, and we will call it as a system constant. See, this is nothing but system constant. And what is the system constant we have seen? System constant will be r by l. R by L, that is what we have seen, right? See, here it is. I will explain you a bit later what is this one exactly. So this is now system constant, right? So now what we can do here, we can write this expression. I'm going to write this expression. See, this one I will call it as y of f, y due to f, forcing function, solution due to forcing function, and this one yn, solution due to natural function. And now what I can write, y of t can be written as two parts. One is solution due to forcing function, and one is solution due to natural function. And try to understand, these two terms should satisfy the differential equation. Should satisfy the differential equation. Now what I can do, so this one d by dt, I am just going to write it down. See, this is now y. Anyhow, I will write it down. A into y, that should be is equal to x of t, right? So try to understand. I will just put it down in the equation, d by dt of yf. I am just substituting this solution inside this y, right? Yf plus this will be now yn plus a into yf plus yn, and that should be is equal to what? X of t. Try to understand. This is very important to know because this one will be directly related to electrical things, right? So this one I will write it down as d by dt of yf, and here I have a into yf, right? So this will be now a into yf plus, I'm just writing d by dt of yn here, d by dt of yn plus then this term, right? A into yn is there, a into yn, and that should be is equal to x of t. See, this one, just be with me because this is very important. See, I'm just going to take this part, only this part. It will be very interesting. See, what is that one? D by dt of, what is y of n? What is y of n? It is a e power minus at, right? So a e power minus at, this one, okay, plus then what is the next one? A into y of n. What is y of n? It will be a e power minus at, right? This one. So you just simplify this, what you will get. So a is the constant term, you take it outside. A is the constant term. If you differentiate this one, what you will get? Minus will come outside. So it will be now a e power minus at, right? Then plus, what is this term? It is directly a. This is directly a into small a e power minus at. What is this one? What is this one? This is 0, right? Both terms will be cancelled out. Both terms will be cancelled out. See, this term will be cancelled out. Solution due to natural function will be always 0. That is what we have seen here. See, that is why I have repeatedly told you this value will be always 0. Will be always 0. Just we are relating, right? Now we are relating. So what is my point? Then this one, this solution due to forcing function alone should satisfy what? The differential equation. So this should satisfy x of t. See, try to understand. D by dt of y of f plus a into y of f should be is equal to x of t. That is my point. This alone, so I will write it down anyhow. Solution due to forcing function alone should satisfy the differential equation. Alone should satisfy. I am just writing because you have to understand this one. Should satisfy should satisfy the differential equation. I'm just writing it down. I will take some time. So this is the point you have to understand, and why I need this one, why I should need this one. And you can write this one as, see, this is the expression, right? This is the expression. Anyhow, I will take up to the okay, fine, I will write it down here. See, y of t now can be written as what? K1 x plus k2 x dot plus k3 x double dot, and it will be going to infinity plus a e power minus at. So this is the y of t, and you can ask that what is this k1, what is this k2. That is the problem here. I need to find what is k1, k2, k3 and so many things. So for explaining this one, let me take an example, one small simple example, so that you can easily understand, right? So that you can easily understand. I will take up to the new page. We know what is the solution. Y of t can be written as what? This one I will just write it down. K1 x plus K2 x double dot, sorry, x dot plus K3, and it will be going on to infinity, and then plus a e power minus at. And what is a here in this expression? What is a? A is nothing but it is 2, right? So a is equal to 2 here. So I can write this expression. First I will write it down, this one, y of t is equal to, I will just write it down this expression, and see, one boundary condition should be given to this, right? So I will just take y of 0 should be is equal to 0, and I will relate it to the electrical circuit. Just you be with me, I will relate it. So y of t, so this one will be now a e power, what is a here? It is 2, so minus 2t. That will be there. Plus, see, now I have to do this one. What I need to do? First one, that is k1. K1 has to be done, has to be written as it is. X, what is x here? It is t square. So you put t square plus k2 is there, and then I am just writing it as k2. X dot, what is x dot? If I differentiate this one, I will just write it down here. Maybe x dot, x which is equal to what first? It is t square. So if I go for x dot, what I will get? It will be 2t, right? 2 into t. So it will be 2t, maybe into 2t plus x double dot. What is x double dot? It will be 2, right? It will be 2. So x double dot will be 2. So 2 in k3 into 2. And what is x triple dot? X triple dot is 0. And what will be x4 dot? X4 dot will be 0. So you see, this term will not go to infinity. It depends on the forcing function. So this will be the expression. And you see, I will directly write this is 2 plus this one will be k1 t square plus, you see, I will just combine these two. This is a constant, right? It will be easy. I will just put it as k2 into t. This is a constant. Constant multiplication of constant will be constant. See, you don't see these kind of 2's here now. So this will be now plus k3. I have just combined. See, you try to do whatever the constant you get, you put it as a constant. That's all. Now you see, this is the solution due to natural function, and this is the solution due to forcing function. See, I have already told you forcing function expression should satisfy what? This differential equation. Then you directly write it down as d by dt of k1 t square plus k2t plus k3 plus this value 2 into this y, k1 t square plus k2t plus k3, and that should be is equal to what? T square. This should be is equal to what? T square, right? You have to write like that. So if you differentiate this one, what you will get? If I differentiate this one, it will be now 2t k1, 2t k1 plus this value now becomes k2, because t, if you integrate, differentiate, it will be 1, plus k3 will be 0, right? There will not be any k3 because it becomes 0. If you differentiate a constant value, it becomes 0. Then plus this value will come 2k1 t square plus this value will be 2k2 t plus 2k3. That should be is equal to what? T square, right? T square. So then I will put as, see, now what you do, you just club these terms. Wherever you see t square, you write down the t square values. So 2k1 t square is the only term, no other t square terms. So what is the other term? Any t terms available? Yes, it is a t term. Here I have a t term. So you write down the t terms plus 2k2 t terms. I have written this t terms. Then everything is a constant, right? This is a t term, right? So this will be now plus 2t k1, right? Then plus I have written this one also. Then this value will be k2 plus 2 into k3, and that should be is equal to t square. You just club it down, so it will be 2k1, it is t square, plus you just take this t commonly outside, what you will get? 2k2 plus k1 plus k1 into t, plus this is the constant term, k2 plus 2k3, that should be is equal to t squared. See, what is this? This is the identity, right? Identity terms, right? So if it is an identity terms, then what you can directly relate, right? You can directly relate this one. So this term should be is equal to t square term. So 2k1 t square should be is equal to what? T square, right? Can you understand? Can you understand? Thus you can relate this to right hand side. So if t square will be cancelled out, and you will get 2k1, that should be is equal to 1, and I can write it as, put a mark here, and I can write it as 1, k1 can be written as 1 by 2. I have found what is k1 directly. So now this term equal to 0, because there is no t term in the right hand side. So what I can do, I can write it as 2k2 plus k1, that should be is equal to 0. So it will be now 2k2 plus 1 by 2, that should be is equal to 0 if you simplify this. So if I simplify this, I will get k2 is equal to minus 1 by 2. And you just see the constant term, there is no constant term. So I can write a constant term like k2 plus 2k3, which is equal to 0. There is no constant term in the right hand side. So you substitute k2 in this expression, it will be minus 1 by 2 plus 2 into k3, that should be is equal to 0. And if you simplify this, so if I simplify this, I am getting k3 is equal to 1 by 4. Now what you can do, you can write in this expression. So y of t can be written as a e power minus 2t plus, what is k1 now? It is 1 by 2 t square plus what is k2? Okay, k2 is minus, right? So minus 1 by 2 t plus, what is this value? Plus, it is k3 is 1 by 4. So this will be the solution. Now this is the solution. This is the solution. Now you can apply the boundary condition to find what is the value of a. So y of 0 is what here? Y of 0 is equal to 0. So you substitute 0 here. See, I have just substituted a. If you substitute 0 here, what you will get? This term becomes 1. So you will get a plus this term becomes 0. This term becomes 0, and you will get 1 by 4, right? 1 by 4. A plus 1 by 4 is equal to 0, and what you will get, a is equal to minus 1 by 4, minus 1 by 4. This is the value. And if you further simplify, or if you write it down, y of t is equal to what you will get? It is minus 1 by 4 e power minus 2t plus, and then you will get 1 by 2 t square plus 1 by 2t plus 1 by 4. Anyway, I will write it as 1 by 4. So this is the final expression. This is the final expression for this first order differential equation. See, this is the, it is very simple. It is very simple to understand now. So we are going to relate it with the electric circuits. Now we have solved the first order differential equation. We will go for the second order differential equation in the next class. So you try to be with me. We will see in the next class. Thank you. See, we have taken a simple example and we try to solve this one by ourselves. See, this one, now this is the equation, first order differential equation, and I am taking the forcing function to be t square here.